So in this video, we're going to talk a little bit about climate. Climate's a little bit different from weather. Weather is the conditions that you're experiencing exactly right now. If it's sunny outside and 70 degrees, that would be the weather. All right. If there's a thunderstorm and 80 degrees, that's the weather. All right. Climate is going to be an average of the weather over many years. All right. So when you're talking about the climate of an area, like let's say that, for instance, we're talking about the climate in Raleigh, North Carolina, where we live. You might say that we have hot, humid summers with relatively mild winters. All right. That would be a description that talks about the climate, the overall weather that we experience here. All right. So one thing about climate is, some years you might have a little bit more rain than others, for example. So in order to talk about climate, generally you want to talk about something that's been going on for at least 30 years. All right. So you want to have about 30 years worth of data so that you can describe the climate. All right. And the purpose of this is so that you don't have, let's say that we have an abnormally wet summer. You wouldn't want to say that that is the climate here, when really that's just, you had a summer where it was relatively wet. All right. So the key thing to remember about climate is that it is an average. All right. And the two things that you're going to talk about when you're talking about climate is temperature and precipitation. So some factors that are going to affect the climate. First of all, latitude. All right. We learned a while ago that the Earth spins on an axis, and that it's this, and as the Earth goes around the sun, this tilt in the axis causes us to have the different seasons. All right. We know that on average, the places at the equator get the most direct sunlight, and the poles are going to get the least amount of sunlight. All right. So your position north or south of the equator, which is what we call latitude, is going to have a big effect on your climate. All right. Generally, you're going to have warm climates near the equator, and you're going to have colder climates closer to the poles. Another thing that's going to affect climate is your elevation. All right. So elevation is your height above sea level. All right. So one thing that we know is that the higher you go up in the atmosphere, the colder the air is going to be. All right. And one way that we would know that is if we looked at a picture of a snow-capped mountain. The reason that there's snow at the top is because it's colder higher up in the atmosphere. All right. So we normally think of some of these things like taiga, tundra. Those are things that you would experience when you went to the North Pole, but you can get similar types of climates just by going up high into the mountains. All right. And the reason is in the same way that the temperature gets colder as you get closer to the North Pole, you get the same type of temperature issues as you go higher up into the mountains. So some things that are going to affect the climate. One thing is going to be topography. All right. And what they mean by topography is just what are the types of land features that you have that the atmosphere is going to encounter as it tries to go over that land. So one thing that we know is that if you have a mountain and the air is coming in this direction, all right, well, if this air is coming over an ocean, it's going to be relatively warm and humid. And when that air hits a mountain, that air is going to get lifted, and as it gets lifted, it's going to cool down. All right. And when it cools down, a lot of that humid air is going to condense out and form rain clouds. All right. So what's called the windward side of mountains, all right, that's the side of the mountain that the wind is coming from. Those tend to get more precipitation than the other side of the mountain. And the reason that the other side of the mountain doesn't get much rain is that all of the humidity, all the water in the air basically got squeezed out on this side. All right. So the humidity that was in the air got cooled down. It caused it formed rain, and then there's no water left to fall when you're on the other side of the mountain. So to give an illustration of a rain shadow, this is using Google Earth. And what this shows right here is the coast of Northern California. All right. So the direction that the winds are generally going to flow is towards the land here. All right. And so what I'm going to do is kind of start moving forward, and you can see how green things tend to be on this side. So the thing is, we're getting higher up into these mountains here, and things tend to be really green and lush. All right. And that's because this is where the air is getting lifted, and you're going to tend to get a lot of precipitation in this area. But as we keep on going up into the mountains, you can kind of see how the mountains are getting closer to us here. All that moisture, once the rain falls, there's not a lot of moisture in that air anymore. And if you keep on going, all of a sudden in a very short area, things get bone dry. All right. And so just on the other side of the mountains, this area doesn't get much rain at all, and that's why you don't see a lot of plants. So again, if we back out a little bit, this side, tons of trees and plants, but on the other side, nothing. So another thing that affects climate is the type of air masses that an area would encounter. So if you live in an area where the type of air mass would be, for example, a maritime tropical type of air mass, which is abbreviated as an MT, all right? Those areas are going to have that warm, humid type of climate due to that type of air mass being close to where you live. Okay, bodies of water are also going to have an influence on the climate. The temperature of the water around where you live is going to influence the temperature of the air that flows over top of it. So if you have air flowing over top of cold water, that's going to tend to make the land close to that colder, because the air is going to pick up the temperature of whatever that water is. All right. One thing about areas near large bodies of water is that they tend to have cooler summers compared to the land further inland, but they also have warmer, or at least milder, winters than the places that are farther inland. All right. And essentially, the ocean protects the land close by from any extreme temperature. It acts as an air conditioner during the summer, and like a heater during the winter. And this right here shows an example of that. All right. So San Francisco is on the coast of California, and because of its proximity to the water, it has actually very cool summers. All right. In July, average high is about 71 degrees Fahrenheit. That is very cool. That's about 20 degrees cooler than what we have here. All right. But in January, your average low is 46. All right. That's a lot warmer than it is here. All right. So since it's on the coast, it has much cooler summers than we have, but it has much warmer winters. All right. All right. And by comparison, Wichita, Kansas, it's in the middle of the country. All right. And you can see by comparison, it has a much hotter summer than San Francisco, but it has a much colder winter. All right. And that's because there's no water around it that can help to protect against these extremes in the temperature. So we were saying that if you live near a body of water, it's going to have a big effect on your climate. But one thing in addition to that is that the type of ocean current in that body of water is going to have a big effect as well. All right, I'm going to switch to this map right here. And you'll notice that, like on the East Coast, we have this warm ocean current that rides up the East Coast. All right. In contrast, on the West Coast, they have this cold ocean current that goes southward. All right. And because of this warm ocean current called the Gulf Stream, this tends to carry a lot of warm, moist air with it. And that's why the East Coast tends to have a humid climate. All right. If you've one thing about California is that it's actually very dry. All right. The air there, it can actually get fairly hot there in the summer, but it doesn't feel that bad because it's not humid. And the reason it's not that humid is that you have this cold ocean current, and that means that the air there just doesn't have a lot of humidity in it. All right, and that has a huge effect on the climate. So again, the East Coast is going to tend to have that those warm currents. That's going to cause our climate to be humid and subtropical. The West Coast is going to have the opposite. It's going to have the cold currents, and that's going to tend to make the climate that's cooler and drier. Okay, and the last thing for this group of notes is that you can have, in addition to a large area having an overall climate, you can actually have what are called microclimates, which are climates that affect just a very small area, maybe like the size of a city. And one of the important microclimates is what's called a heat island. All right, and that's something that you're going to see around a lot of urban areas. And one thing that happens is that in a lot of cities, you don't. A lot of the trees have been cut down, and you have a lot of places that are paved over, and you have a lot of objects that just tend to absorb heat more. All right, and so if you live in a city, the temperatures are going to tend to be a little bit warmer than if you live in the countryside right out here. All right, and so one of the things that affects that is you're going to have a lot more places for water to exist out in the country. And when that water evaporates, that has a cooling effect, all right? And since there aren't going to be nearly as many lakes and places for water to be in this largely paved area in the city, it's going to tend to be a little bit warmer.